What's up, people? Welcome back to Algebra 1, Miss Lake's class. We're working on lesson 3.2 today. Get ahead in your math.
The homework.
The homework.
All right, great job. Okay, starting with question 1. Everybody's on the homework. You're on your own. And everybody has their notebook open so we can take notes while we're doing this, right? I don't see notebooks, I want to see notebooks open. This is number 1 on homework 3.2. Let's see how far we can get through it today. Given the following functions, find the indicated values. So we're going to do 3 problems in 1. First, we're going to use this function, this little machine, and see what happens when we plug in a -5 for our x value. That's what this is. So what this is asking us to do is, for the function of x, this is a brand new marker and it seems like it's not even working. Function of x equals 1 minus 7x. It's not totally in slope-intercept form, but it doesn't really matter in terms of just plugging in your numbers, right? Okay, so for this, our first one is we're looking for the function of -5, which means what will be your output when your input is -5, when you put in a -5. So the function of -5 equals 1 minus 7 times -5. I don't like this marker at all. I'm switching it. I don't know if it's dried out or what. Did you guys see that? Nothing but net. Okay.
Wait, where did you get 0.5? Sorry, no.
Oh, whoops!
0.5.
Oh my gosh, it's Jolly Rancher time already? Okay, it should not be 0.5, it should be -5. And look, I have all these blues. You like the blues?
Yeah.
All right, then find my mistake. You gotta be following along. So, remember, this part doesn't mean to multiply. This part isn't saying f times -5. This is just saying the function of -5, meaning what will happen when -5 goes into the machine, what will come out, okay? So now we just solve. There are 2 ways to look at this. You can either say we have 7 times a -5, and that would be what? What's 7 times -5?
In -35?
Yeah, -35. So we would have 1 minus -35. The other way you can do this, because we could have 1 minus a -35, which would be what? Kill the cockroach, change the sign, and you get
36.
36. The other way to look at this is you can assign this minus sign to the 7, and you can say it's 1 plus a -7 times -5, which is what?
35.
Positive 35. That's actually kind of easier, right? Because you don't have to kill any cockroaches. 1 plus 35 is 36. So that means the function of -5 equals 36. Your values might be different than my values, but the process is exactly the same. It doesn't make any sense? Oh. Oh, you were here on Friday. Okay. I can go over this one during lunch with you, or if we have time after this is over. But let me just go through these. Just follow along. All we're doing is, all this means, it's the only reason it doesn't make sense to you is because you weren't there for when we worked out what things mean. This is a linear function, which is the same thing as a linear equation. This f of x means the same thing as y. So what we're doing is it's saying what will happen if you put a -5 into this equation. The equation acts like a machine. We call it a function because it functions a certain way every time. If you put a -5 into this machine, the machine is going to multiply that -5 times a -7. Then it's going to add 1 to it, or it's gonna do 1 minus that product, whatever, however you wanna think of it. Then what spits out of the machine is going to be a 36. So in that machine, if you put in a -5, what's gonna come out is a 36 every time. That's a function. So all this question is asking you to do is saying this machine does the same thing every time, but the output is going to look different depending on what number you put in. So when we put in another number, what comes out, or the output, what gets put out, is going to be a little bit different, most likely. Okay? So I'm just gonna submit that and move on.
So do you do the same thing with the other point, kind of?
You do the exact same thing, it's the same function, it's just saying, now try it for 0. Put 0 into the machine.
Wouldn't it just be 0?
Let's see. The function of 0, meaning
No.
what's gonna come out when 0 goes in, is going to be 1 minus 7 times 0. What's -7 times 0?
0.
0. 1 plus 0 is 1. So the function of 0 is 1. When you put a 1 in, when you put a 0 into the machine, and the machine does this to it, it spits out a 1. Or puts out, which is why we call the output. Good. Are you guys getting the same numbers or different numbers?
Different numbers.
Okay, that's okay. This is more about the process than the actual answer.
I can understand this better than the video than
I know, it's hard. I did what I could do. It was either that or just read it on your own. Besides, you can always watch the video at home too, and without the distractions of class. Now, same machine, same function. What happens to an 8 when we put it in? The function of 8 is 1 minus 7 times 8. So we do a -7 times 8 and we get negative 56, and we have a 1 minus 56, we get kill the cockroach, change the sign.
Wait, do we have to do it that way this time?
That's how I do it every time there's a anytime I have a subtraction problem that's gonna cause a problem, like if I'm subtracting a bigger number from a smaller number, yeah. So 1 plus -56 would be what? Yep, -55.
Wait, so would how would mine be?
You would have to figure that out. I
know.
know.
Yeah,
I'll give you a second to do it while I skip to the next problem. And I'm just checking my answers just in case I make a silly mistake. I don't want to do the wrong thing. All right, let's go to the next one. All right, this is asking us to do the exact same thing. It looks like the instructions are different, but it means the same thing. Find the value of the function of 3 for the function. Here is our function. Here is the machine.
It sounds wrong. Like my
Yours was wrong? Okay, so you probably didn't do your math right. Meaning,
I mean, did you count the subtraction as a negative?
you had a different thing
I
than me,
know.
right? Yeah. It just depends on, you want to look at it real quick?
Yeah.
So what did you have to put in? A 7? Okay,
Yeah.
so that'd be negative 28. So this would be negative 27.
Oh.
Okay. So now it says find the value, you're welcome, of the function of 3 for this function. This is the machine. When you plug in a 3 or put in a 3, that is your input. You're putting it in. Hands up, Ricky. Just a quick check. Quick little checky check. Yeah, dude. Good job. I'm just making sure you're on. Whoa, I'm tripping over my little Elsa veil here. Making sure everybody's on task. Okay, so this is our machine. We're gonna throw a 3 into the machine, turn it on, see what comes out, okay? We watched Dennis the Menace with the kids a few weeks ago. Did you guys ever see the old Dennis the Menace?
Yes.
Where like, he vacuums up the paint, right? The paint goes in, and then he pushes the button, and the paint goes out, and where does it land? On Mr. Wilson's chicken. Okay, input and output. Okay, are you good? Are you focusing on it? Oh, you're watching the video? Okay, and then you'll watch this one later, right? Okay, sounds good. Okay, so when we put the 3 into the machine, what's gonna get spit out? Well, the machine says to do all this to it, but we're gonna write it in function notation. So the function of x, which would be replaced by 3, it's just saying that this is gonna be our output. The function of 3 equals -6 times x plus 2, but we're gonna replace our x with the 3. We have to plug in the 3. And then we just solve. I know you guys love to distribute, but it's also really simple if you just solve what's inside your parentheses. Distributing is only it's really meant for like if there's like a variable involved. But since we can solve what's in here, we do 3 plus 2 is 5. 5 times -6 is what? Oh, I'm sorry, you guys are probably working on your own problems, right? -6 times 5 is -30. So we get the function of 3 equals -30. So do you see how that problem is just like the other ones?
Would -5 times 4 be -20?
Correct. What I would suggest for you, Emily, is try to do it mentally first and then just double check your answer on the calculator.
Oh, okay.
So at least you get the practice of doing all the good stuff in your head, and then you can just double check it. All right, another one that's exactly the same thing, but it's just a different machine. We're going to find the value of the function of 4. All that means is plug your 4 in for your a. So we're going to do the function of a, which we're replacing with 4, equals 5 times a, which we're going to replace with 4, plus 3 minus 9. Now we just solve. Remember, this is just saying what happened in the machine. What is coming out of it. We're not solving this, we're not distributing it, we're not multiplying it. It's basically just saying what comes out. This is your y term. What comes out. This is your output, also known as your range.
On
Okay.
the test that we have to, on the test, or a test.
It would look just like this.
Oh, okay.
I'm just showing like all of the why and who and what behind it. Okay, so remember you can distribute, but it's easy when you have numbers and not variables. Just go ahead and simplify that. 7. Now remember order of operations. We have to do our multiplication first before we do the subtraction. So 5 times 7 is 35 minus 9 is 26. Is that right? Somebody catch my mistake if I do bad math. The function of 4 is 26. Do you guys see how this is actually super simple? It's just getting used to function notation, writing it in that way. So the function of 4 is 26. Fantastic. Okay, here's another one.
This one's weird.
Does it look weird?
Mm-hmm.
Uh-oh. Evaluate f of x at the given values of x. So it's saying that x is -3 and x is 5. It's kind of like saying, if you plug in -3 for your x, what's going to come out? Which is your y value, right? Your y coordinate, but we write it as f of x when we're talking about functions. So if we put in a -3, what's going to come out? We don't know yet. And then we're also going to find out if we put in a 5, what is going to come out.
What do we put for the FX?
What do we put for the fx?
Yeah.
Let me get there in a second, okay? So we're trying to find two different values. What comes out when we put in a -3 and what comes out when we put in a 5. We're going to have to solve this separately, okay? See how this says the value of f of x for x equals -3 is, so we're only looking for one answer at a time. So the first thing we're going to do is f of x equals 5x, but we're going to plug in our -3. F of -3 equals 5 times -3. What's 5 times -3?
Wait, so we have to multiply them? We're trying to make what?
Okay, let me start it again, okay?
Sorry.
It's okay. This is our function. I'm going to write it over here. F of x equals 5 times x. It says evaluate the function at the given values of x. Our first given value is -3. That's our input. This is the machine. The machine takes whatever you put in and multiplies it times 5 and then spits it out. So when we put in a -3 and that -3 gets multiplied times 5 inside the machine, it becomes a -15. So the function of putting a -3 into the machine is going to spit out a -15.
So we have to multiply them?
You do whatever the function says to do. The function said to take x and multiply times 5. That's what 5x means. This is your function. These are the x values that it's giving you. You know what's kind of weird? That this is so close together that it looks like 5xx. Ignore that part. It's a little strange. That's why I kind of boxed this to say this is your function and that is it for your function. I know you're used to seeing a function as like 5x plus 3 or 5x minus 9 or something a little more complicated. This doesn't have a y-intercept, so it's just 5 times x. It's saying what happens when you plug in a -3, what's going to be your y value, what's going to be your output. What is the function of -3? So what comes out is a -15. Then we'll start it over, completely new input, but totally same function. This function takes whatever you put in, multiplies it times 5. So when we are trying to find the function of 5, that means we take our input, which is 5, our x value, which is 5, we throw it into the machine, and the machine is going to do the same thing that it did when we put in a -3. But it's going to come out different, because 5 is a different value than -3. When 5 goes into the machine and it multiplies it times 5, what do we get? 25 is correct. So the function of 5 is 25, meaning 5 is your input, 25 is your output.
Where did the 15 go?
The 15 is the answer for when x equals -3. That would be 15. See how I charted it up here? When I put in a -3, which is the first question that they're asking, I get out a -15. Whoops, that's supposed to be -15. Yeah.
I got the same exact question as you.
Oh, you are a lucky duck, aren't you?
No, I just had to keep rolling my questions so I got the same thing.
Oh, that's a good idea.
I tried that, it didn't work.
It didn't work?
So I just left it as.
Okay.
It's literally guaranteed.
Then see how after I gave the first answer, now it's asking me for the next answer when I plug in a +5 and I put it into the machine, I got a 25 output. So So I put in my 25. I'll come check yours in a second. I wish it would just automatically go to the next question instead of making me click it. Oh wow, that's quite a chart. Okay, let me see yours.
Finally. Okay. I just hit like the squidgy thing and that's what I got.
Okay.
I don't know what I'm doing.
Okay. Did you plug in you plugged in your -3? Did you plug in your -3 yet? So it says so you have the exact same function that I had. And your first x value is the exact same first x value that I had.
Yeah, but like, I don't know.
Okay.
I don't know what to do.
Okay, you take the -3, which is your x value. Your x value is your input. It's what you're putting into
so
the
it's still
machine.
like be 15, like
-15 would be the output. When we plugged in -3 for our input, our x, the machine multiplied it times 5, which is what we have to do. We have to be the machine, right? And we get a -15. That's the answer. That's the output.
Yeah, but that was the second part.
The second part is, what value did you get, a 4?
Yeah.
Okay, so it wants you to try to put a 4 into that machine. So you take your 4 and you throw it into the same machine that functions in a way that multiplies the 4 times 5. That machine, every time you put a number into it, it multiplies it times 5. And that's all it
So
does.
it's just 4 times 5.
Yeah. Do you get that the machine, like, all it's doing is like exactly what it says? If the machine says that whatever x value it is, it will multiply that x value times 5 and spit it out. Do you get that?
No, that should it should be the 3.
It's kind of like if you put something into the washing machine and add red food coloring to it. Let's say you put a sock into the washing machine and
One
add red
singular
food.
sock.
You're going to get, the output is going to be a red sock. If you put in a different input, like a white shirt with red food coloring, same function, it's still going to dye it red, but it will come out a red shirt instead of a red sock. It's still doing the same. If you have the same function, you're just putting in different inputs. If you put in a white sock, it's going to come out a red sock. If you put in a white shirt, it's going to come out a red shirt. So it's still doing the same thing. The output will look a little bit different based on what we put into it. It'll still be red though. So this is multiplying it times 5 every time, but the number will come out different if you put in a different input. Does that make sense? All we're doing is plugging in numbers. All right, let's see. Use the table below to determine whether the function of x could represent a linear function. If it could, write f of x in the form of what we would affectionately call slope-intercept form, but with function notation. Now, remember, oh, I got to minimize this just a little bit. Okay. Remember, this function notation really means the same thing as y equals mx plus b. Every time you see function of x, it really means the same thing as y. The reason I keep saying that is because we're much more familiar with this equation. This is a linear equation. This is a linear function. They look exactly the same on a graph. Okay? They still both look like lines on a graph. They'll still be the exact same line on a graph, depending on what you're working with. Now, let's look at our table. Remember, if this is x, we know it's x. If this has f of x, what does it really mean? What does f of x really mean? It means y, right? And you don't have to change this. I'm not going to cross it out. I'm just going to show that, just a hint to myself, because we always think of a coordinate pair on a graph as the x and y value. So these values, this is an x value, this is a y value. this is a coordinate pair, 0, -5, on a graph. But it's just using the fancy function notation, taking y and calling it f of x.
So why can't they just use y?
Because
They want to be
because the function notation really represents more like real life situations. Like when you have a business situation, like what they were kind of describing this morning with the banks, like with a loan or with something like this, what goes into it is going to give some sort of output depending on what happens in that function, whatever happens in that business model. On Friday, we talked about the girl that made bracelets, and every time she made a bracelet, it cost her $15 extra to make the next bracelet. It wasn't getting doubled or tripled or anything like that. Every time she made a bracelet, it would cost $15 extra. It wouldn't cost twice as much as the first one. It would cost $15 more. So that's a model of what really happens when we have a function. So this is a coordinate pair, 0, -5. This is our x, this is our y, but our y is also called f of x. We just need to get really familiar with that. Now, all it's asking for now is determine whether this function of x could represent a linear function. And a linear function means, does it form a line? The way that a line can be formed is it has to either increase steadily or decrease steadily, or stay exactly the same, right? But that's also steady. A line can only be a line if there is a consistent change in the y values over a consistent change in the x values. Like our rise over run. Every time we go from one point to the next, it goes up 2 over 1, up 2 over 1, up 2 over 1. So a line is really formed by like a perfect staircase. It goes up, over, the exact same every time. That's the only way you can form a line. If somebody's making bracelets, and every time she makes a bracelet, the first time to go from one bracelet to the second bracelet, it increases, she needs $15. To go from the second bracelet to the third bracelet, it costs $10. And to go from the third bracelet to the fourth bracelet, it costs $20. It's gonna zigzag. That's not a linear function. A linear function has consistency. And we call that consistency a slope. The slope is the change in y over the change in x. We also know slope in slope formula, which is y. Why would I draw a 7 when I know to draw y? Y, the second y minus the first y over the second x value minus the first x value. That's what a change is, finding the difference between two y values. What is the difference between a -5 and 0?
It's going up by 5.
Yeah, it's going up by 5. It's increasing by 5. What is the difference between 0 and 5?
Going up by 5.
Up by 5. What's the difference between 5 and 10?
Up by 5.
Good. So what's our change in y?
It's going up by 5.
Up by 5, so that'd be positive 5, right? What's my change in my x value? 0 to 1?
It's going up by 1.
Good. 1 to 2?
1.
2 to 3?
1.
So what's my change in my x?
1.
1.
So it'd just be 5.
So our slope equals 5. So right away, we can see that there is a consistent change. Every time the y goes up 5, the x goes over 1. Every time the y goes up 5, the x goes over 1. Up 5 over 1. Up 5 over 1. That staircase forms a line. This is just going up and over to get to each next point. I know, it is steep because it's going up 5 and only over 1. So that's a line. So So we can see here that because of this consistent slope, it does represent a linear function. Now that we've established, so this function is not linear, that's not going to be correct. The values could represent the linear function. F of x equals what? Well, now we have to put it in our function notation.
Oh, so you have to put it like that now?
Yep, so you have to have f of x, which they give you here, equals, now we need mx plus b, but we've already figured out our m. Our slope is 5. So 5x plus b. And the only other thing we need to fill in
Is that
here,
it?
not yet. The only other thing that we need to substitute is our y-intercept. Now, when we were working with linear equations, before we ever talked about functions, we figured out how to find a y-intercept using the information that it gave us. We figured out our slope. We need to solve for b, which means we need to replace this with a value and this with a value in order to solve for this variable. What values can we plug in using our information? And, yep, we can use any coordinate pair. I could choose anyone. I could even choose this one because it might be easier because there are no negatives. Let's go with that. Let's plug in 1 for x. So 5 times 1 plus b equals the function of x. The function of x for that pair would be 0. And then we solve. 0 equals 5 plus b.
Should I choose the other one?
Why?
Because
I can
want
just
that one.
subtract 5 and subtract 5. What's 0 minus 5?
5, yeah. Wait.
If I have
Okay.
$0 and then somebody says, give me $5,
Oh.
what do I have?
$0. Negative 5.
Negative $5 because I owe them $5. So negative 5 equals b. Now, I have my slope is 5, my b, my y-intercept is negative 5. Now I can fill it in. The function of x is 5x minus 5.
What did you do?
Okay, I am writing my function notation,
Yeah, but like, what
filling
did you do
in
with the
5 for my slope and minus 5 for my y-intercept. And function of x equals 5x minus 5. That's it. That's the function. What happened?
Like, what did you do with the points that you picked?
Oh, I used them and abused them. I don't need them anymore.
Yeah, but like,
All I
what
needed,
did you do?
I used them to solve for my y-intercept so that I could fill in my y-intercept in the function notation. Function notation.
So do I just multiply them?
Multiply what?
The points that you picked.
You do whatever the function tells you to do.
But what is it telling me?
What you tell me, is your function different than my function?
Yeah.
Okay. What is your function saying to do?
Determine the points that could, whether fx could represent a linear function.
Okay. Did you find the difference, the changes in your x and compare with the changes in your y? What was it?
Was 2.
So your change in y was 2 over 1? Okay, so your function is 2x because that 2 represents your slope. See, we had 5 over 1, so our slope is 5. You have 2 over 1, so you have f of x equals 2x plus b. So you have to take any coordinate pair from there that you want, plug it in for your x value and your y value, your f of x value, solve for b, and then rewrite your function, filling in your slope, which would be 2, and your b value, which would be whatever you get when you plug in your coordinates. You get that? What are your coordinates? Let's plug them in.
1 and 3.
So x is 1.
No, x is 3. 3 and x.
Okay, so tell me your coordinate pair in order, x, comma, y.
Oh, like the one like.
Go to your table,
Okay.
go to the table that it gives you. It tells you all of the x values and all of the y values, which are in the table are called function of x, okay? Each one of those is a coordinate pair. They are written on top of each other, but it tells you which one is x. So you have to read them to me according to, or you could say x is this and y is that. That would be fine. But you can't just tell me two numbers in any order, because then I won't know where to plug them in.
So like the one I chose is 3 and 1.
Good. So are you giving that in order, where your x value is 3 and your y value is 1? Okay, you're sure that the 3 is in the x column? Okay, or the x row? Okay, so if this is my x and this is my y, which is also called function of x, that's where I'm going to start plugging in. I have 2 times x, so I'm going to do 2 times 3, plus b. B stays the variable because that's what we're trying to solve for. And then we're replacing the function of x with our y value, 1. It's our output. So then we multiply 2 times 3 is 6. 6 plus b equals 1. Solve algebraically. Subtract 6 to cancel out. Subtract 6 to the other side. And you get -5 equals b. Hey, look, our y-intercepts are the same. That's pretty cool.
So just be, wait, so just be 2x plus -5.
That's correct, but instead of saying plus -5, you just write -5. 2x minus 5. Not yet. I want to see.
Oh, the next question is different.
The next question is different. The linear function. So this question, I'm just going to talk through this for the next 2 minutes. This question is exactly the same. The only difference with this question is it says to write the linear function. It doesn't ask you if it's a function. It's telling you that there is a consistent change in x and a consistent change in y. But you solve it the exact same way. Find your slope, plug it in, along with one of your coordinate pairs, solve for your y-intercept, and write your function using your slope and your y-intercept. Let me just go to the next one.
Oh, it's
Yep. So all we're doing is graphing this. This is the exact same thing as graphing y equals 1/4. I need silence. Y equals 1/4 x plus 6. That's the exact same thing. You can write that in slope-intercept form with the y. And then we just have a +6 as our y-intercept. Plot that first. Then go up 1/4. Plot the next point, and you've got a line. Up 1 to the right 4, and then you've got a line. Linear functions work just like slope-intercept form. Okay, same exact thing here, except you're going to need to distribute to get this in slope-intercept form. So you'll need to multiply. Let's see, what's 0.25 times 6? Can somebody get that? 1.25, thank you. 1.25 minus 0.25, x plus 5. We're going to have to combine like terms. 1.25 plus 5. No, you guys, yeah, you can go. You guys stay. We have lunch. 1.5, thank you. So we're going to combine these terms. 1.5 plus 5 is 6.5. So we have 6.5 minus 0.25x. I'm going to rearrange this commutative property of addition. So I'm going to put my x term over here, negative 0.25x plus 6.5 0.5 equals f of x, which we also know is the same thing as y. When we graph that, and we have to, this is our y-intercept, so plot a point at positive 6.5 on the y. This is our slope. We like our slope in fraction form, right? So how would we write that in fraction form? Negative 1/4 x plus 6.5. Plot this, then go down 1 to the right 4, and plot your second point. That's it. That's all the homework.